the course Design of Reinforced Concrete Structures. In today's lecture, we shall solve a few problems on design of shear reinforcement. So, here is a problem. So, first let us see the question. So, what is the question given here? An RCC beam 230 mm wide and 450 mm deep is reinforced with 4 bars of 16 mm diameter and of grade Fe415 on tension side. So what is given here? Here it is given there is a reinforced cement concrete beam. So first let us write down the given data. So what are the cross-sectional dimensions of the RCC beam? That is, the breadth is given as 230 mm and 450 mm deep. That is, the overall depth of the beam is given as 450 mm. And what? It is reinforced with 4 bars of 16 mm diameter and of grade Fe415 on the tension side. So if reinforcement is provided in the tension side, then what kind of beam it is? It is a singly reinforced beam. So how many number of bars are provided? 4 number of bars, and the diameter of each bar is 16 mm. The diameter of each bar is how much? It is 16 mm. So from this what we can find out? We can find out the area of steel AST. So how can you find out the area of steel? It is 4 into pi d. What is the diameter? It is 16. So pi d square by 4, which will give you a value of 804.25 mm square. So if you solve this, you will get a value of 804.25 mm square. And what is the grade of steel here? The grade of steel is Fe415. So Fy will be 415 Newton per mm square. And what is asking to find out here? Is asking to design for the shear reinforcement. So, and he has given the other data also. What was that? The design shear force is 60 kN. So, Vu, that is the design shear force is given here. So, what is the design shear force here? It is 60 kN. And what is asking to find out? He is asking to design the shear reinforcement which will consist only the vertical stirrup. So in the previous class we have already discussed that what mostly we will use the vertical stirrups only. So here we have to design for the vertical stirrups and use M20 grade of concrete. So FCK, that is the grade of concrete, is given as how much? It is 20 Newton per mm square. So this is the data what he has given here. So what we have to find out here? We have to find out the area of the shear reinforcement, that is ASV, and also we have to find out the spacing of the shear reinforcement, which is SV. So what is the first step what we have to do in the design of shear reinforcement? So the step 1 what we have to do is we have to calculate the nominal shear stress. So first let us calculate the nominal shear stress. So the formula for calculating the nominal shear stress is tau V is equal to Vu by Bd. Tau V is what? Tau V is nothing but the nominal shear stress. It is equal to Vu by Bd. So Vu is nothing but the design shear force which is given in the question. So how much is Vu? It is 60 kilonewtons. That is 60 into 10 cube newtons divided by B. So what is B here? B is given as 230 mm into D. D here is what? D here is the effective depth. But in the question they have given us the overall depth of the beam. So first what we have to do, we have to find out the effective depth. So for that what I am doing, I am assuming a suitable effective cover. So I am assuming the effective cover as 50 mm. So if you will assume an effective cover of 50 mm, so what will be your effective depth D? D will be overall depth minus the effective cover. So let me write it down here. D is equal to D minus the effective cover. So what will be your effective depth D? It is 450 minus 50, which will give you 400 mm. So D here is your effective depth. So 230 into 400. If you solve this, you will get a value of 0.652 Newton per mm. So what is your nominal shear stress now? Nominal shear stress tau B is equal to 0.652 Newton per mm square. So what is the next step what we have to do? So we have calculated the nominal shear stress. Now we have to calculate the shear resistance of concrete or the shear strength of the concrete. So the second step is to find out the tau C, that is the shear resistance or the shear strength of the concrete. Now step 2. Step 2 is what? We have to calculate the shear strength of concrete. That is, we have to calculate the tau C. So to calculate the tau C, what we have to do? First, we have to find out the percentage of reinforcement. That is, percentage of steel reinforcement is what we have to find out first. So how will calculate the percentage of steel reinforcement? We have a formula, that is AST by BD into 100. So by using this formula, we have to calculate the percentage of the steel reinforcement. So AST is already known here. We have found it out. How much is the AST? It is 804.25 divided by B. B is the breadth, which is 230 mm into D. What is D? D here is the nothing but the effective depth, which we have calculated previously, which is 400 mm. So how much is D here? D here is 400 mm into 100 will give you the percentage of steel reinforcement. So if you calculate this, you will get a value of 0.874. So 0.874 is going to be your percentage of steel reinforcement. So now what we have to do? From the percentage of steel reinforcement, we have to calculate the shear strength of the concrete. So how will we calculate that? So that can be calculated by using the table 19 of IS 456-2000. So in table 19 of IS 456-2000, we have values for percentages of steel and for different grades of concrete. So what is the percentage of steel value here? The percentage of steel value is 0.874. And what is the grade of concrete here? The grade of concrete is 20 Newton per mm square. So now what we have to do is we have to refer to the table 19 of IS 456 and we have to calculate the tau C value for this percentage of steel 0.874 and the corresponding grade of concrete being 20 Newton per mm square. So what is the percentage of steel value here? The percentage of steel is 0.874 is what I have got here and the grade of concrete is 20. So in your table 19 of IS 456-2000, you will have different values for percentage of steel and for different grades of concrete. So here I have got the value of 0.874. Okay. What you have to do there, you have to check if there are any tau c values available for this percentage of steel and this grade of concrete. But if suppose if they are not available, then what you have to do is you have to take the value previous to this percentage and later to this percentage of steel, and you have to interpolate and you have to calculate the tau c value for this percentage of steel. So in table 19, for 0.75 of percentage of steel, my tau c value is 0.56, and for 1% of steel, my tau c value for M20 grade of concrete is 0.62. Now my percentage of steel, that is 0.874, lies in between these two, is it or not? So 0.874. So corresponding to this, okay, I have to find out the tau c value. So these are the tau c values for M20 grade. So now how can I find out this? By interpolating. So interpolating, I can find out this percentage, that is this tau c value for this percentage of steel reinforcement. So interpolate it. So if you interpolate, how you can interpolate? 0.874. So if you will solve this, you will get the value of x. So you will get the value of x as 0.589. If you solve this, you will get a value of x, that is 0.589. So what is x here? X is nothing but the tau c value. So corresponding to this percentage of steel, that is 0.874, what is the tau c value? That is the shear strength of concrete. It is 0.589. So what is the tau c value I got here? Tau c is equal to 0.589 Newton per mm square. So what is the tau c value I got here? Tau c is equal to 0.589 Newton per mm square, corresponding to this percentage of steel. So this is the second step what you have to do. Now next what? We have to find out the maximum shear stresses in concrete, or we have to calculate the tau c max value. So the next step what we have to do is we have to find out the tau c max value. So what is the tau b value I have got? The tau b value I have got is 0.652 Newton per mm square. And the tau c value I have got it as 0.589 Newton per mm square. Now the step 3 is to calculate the tau c max, that is the maximum shear stresses in concrete, that is the maximum shear stress in concrete. So from where can you find out this tau c max? This tau c max can be calculated or can be found out from the table 20 of IS 456-2000. That is what? The table 20 of IS 456-2000. So in table 20 of IS 456-2000, we have different values of tau c max for different grades of concrete. So we have different grades of concrete like M15, 20 and all. So for different grades of concrete, you have different values of tau C max. So if you refer to this particular table 20, you can get the value of tau C max. For here the grade of concrete is how much? The grade of the concrete is 20 Newton per mm square. So what will be the tau C max from table 20? The value of tau C max given in that particular table 20 is 2.8 Newton per mm square. It is what? 2.8 Newton per mm square. So that is the tau C max value for grade of concrete 20. For the grade of concrete 20, the tau C max value is 2.8 Newton per mm square. So we have calculated the tau C max also. Now what is the next step? What we have to do? We have to compare the nominal shear stress and the shear strength of concrete as well as the maximum shear stresses in the concrete. That is, we have to compare the tau V, tau C and tau C max values. So now let us compare the tau V, tau C and tau C max values. So now what? We have got the tau V, tau C and tau C max values. Now compare this. So in the previous classes we have already discussed that we have three cases. So what are the three cases? In one case, if tau V is less than tau C. The other case is if tau V is greater than tau C, and the third case is tau V greater than tau C max. So we have to check for all these cases now. So if you observe here, what you can see here, what is the value of tau V? It is 0.652. Tau C is 0.589 and tau C max is 2.8. So that what you can observe here, that tau V is greater than tau C. Is it or not? So the value of tau V is greater than the value of tau C. So if tau V is greater than tau C, what is the other thing you have to check for? You have to check for if tau V, if it is greater than tau C max or not. If tau V is greater than tau C max, then what you have to do? You have to redesign the section. So tau V should be less than tau C max. Then only you can go for the design of the shear reinforcement. So if tau V is greater than tau C max, you have to redesign the whole section. So if you observe here, tau V is less than tau C max. So what here and here what you can see, that is tau V is less than tau C max. Tau V is less than tau C max. So if tau V is greater than tau C and tau V is less than tau C max, then what you have to do? You have to provide or you have to design for the shear reinforcement. So what here? We have to design for the shear reinforcement. If tau V is less than tau C, then what? You have to provide minimum shear reinforcement. But when tau V is greater than tau C, then you have to design for the shear reinforcement. So now let us design for the shear reinforcement. Now we have to design for the shear reinforcement. So for designing for the shear reinforcement, first what we have to know, we have to find out the shear force which has to be resisted by the shear reinforcement. So in the step 4, let us find out the shear force. So the step 4 is what? The step 4 is to find out the design shear force which has to be shear reinforcement. So let the shear force be VUS. So in the IS 456-2000 we have a formula for finding out the shear force which has to be registered by the shear reinforcement. That is VUS is equal to VU minus tau C into BD. So VU, it is already given. How much it is? 60 kilonewtons into 10 to the power of 3. In newtons I have converted that into. Minus tau C. Tau C is 0.589 into B. B here is 230 mm into D. How much is D here? D here is 400 mm. So from this you will get a value of VUS as 5812 newtons. So the design shear force, okay, or the shear force which has to be resisted by the shear reinforcement is how much? It is 5812 newtons or 5.81 kilonewtons. Now what? Now we have to find out the area of the stirrups, or we have to find out the ASV, that is the area of the stirrups what we have to be provide or what we have to provide. So let us find out the area of the stirrups, that is ASV. So now let us find out ASV. So for finding out the area of the stirrups what we have provided, I am here assuming the dia of the stirrups as 6 mm, that is I am providing diameter of the stirrups as 6 mm and let it be a two-legged stirrup. So what I am providing a two-leg stirrup and the dia of the stirrup is 6 mm. So how will we find out the ASV? ASV is equal to, what is the legs? How many legs? 2 into pi d square by 4. Here d is how much? Here d is 6. 6 by 4 whole square. So from this we will get the area of the stirrups. ASV as 56.54 mm square. So how much we will get the area here? Area as 56.54 mm square. Now we have calculated the area of the stirrups. Now what? We have known the area of the stirrups. Now we have to calculate the spacing of the stirrups. So if we provide the stirrups, at what distance center to center the stirrups has to be provided is what we call it as spacing. So now let us find out the spacing required for the provision of the stirrups. So in the question what it is given, that the shear reinforcement is to be designed consisting only the vertical stirrups. So considering the vertical stirrups, so here what we are designing for the vertical stirrups. So we have to use the formulas of the vertical stirrups for finding out the spacing. So first we have 4 cases here. Out of all the 4 cases, whichever is less spacing, that spacing is what we are going to provide here. So first, in the next step, we are going to calculate the spacing. That is, we are going to calculate the SV. So, for the shear force which has to be resisted, I am going to calculate the SV. So, what is the formula for vertical stirrups? It is VUS is equal to 0.87 Fy into ASV into D divided by SV. So here Fy is nothing but the grade of the steel. What you are going to provide for the stirrups? So for stirrups you can either provide grade of steel as 250 or grade of steel as 415. Okay. So here for suppose I am providing the grade of steel as 415. So Fy will be 415. ASV is the area of the stirrup reinforcement what we have already found out, which is 56.54 mm square. D is nothing but the effective depth, which is 400 mm, and VUS is the value what we have calculated previously. So what is the value of VUS we got? VUS is equal to 5812 newtons. So substitute all the values here so that you will get the value of SV. So SV is equal to 0.87 into 415 into 56.54 mm square into 400 divided by 5812. So from this you will get the value of SV as 1404.93. So you are going to get a value of 1404.93. Now we have got this. So this is the case 1. So what is the next? The second case is we have to find out what is the minimum spacing required. So now we have to calculate the spacing from minimum shear reinforcement. Okay. Now the next step is to calculate the spacing from minimum shear reinforcement. So what is the formula for calculating the spacing from minimum shear reinforcement? ASV by B into SV greater than or equal to 0.4 divided by 0.87 into Fy. So we have already calculated ASV. Substitute the value there. It is 56.54 mm square divided by B. B is how much it is? 230 into SV. SV is what we have to calculate. 0.4 divided by 0.87 into Fy. Fy is nothing but the grade of the steel, which is 415. So from this we will get a value of SV as 221.88 mm. So the spacing, okay, from minimum shear reinforcement, or for the minimum shear reinforcement is 221.88 mm, or you can approximately take it as 222 mm. So in IS 456-2000 for maximum spacing, what we have? We have two formulas. That is for the vertical stirrups. One is the maximum spacing, or the spacing what we have provided should not exceed 0.5D, and the other case is it should not exceed 300 mm. Now let us calculate this 0.75 into D. D is how much here? It is 400. Will give you 300 mm and 300 mm. That is the second case. That is for the maximum spacing. Now which spacing you have to consider here out of all the four spacings? You have you have to consider the least one. Out of all the 4, whichever is less, that spacing has to be considered in the design. So from all the values, which value is the least? This value is the least. So what we have to do? We have to provide a spacing of 221.8 mm. That is approximately, you can take it as 222 mm. So hence here we have designed the shear reinforcement. So what is the design? We have to provide mm 2-legged stirrup of spacing center to center 222 mm throughout the length. Throughout of grade FE41. So this is the shear reinforcement what we have designed for this particular beam, for this particular RCC beam. So what we have to do? You have to provide the vertical stirrups. That is a 2-legged stirrup, and the dia of each stirrup being 6 mm, and the spacing of each stirrup center to center is 222 mm, and the grade of the stirrup is FE415. Now let us solve another problem. So the question is a T-beam section having 230 mm width of web and 460 mm effective depth is reinforced with fine number 16 mm diameter bars as tension reinforcement. So here what he has given? He has given the section here is, it is the section T section. Here what it is given? The T section is given, and the width of the web of the T section is 230 mm, and the effective depth is how much it is? 460 mm. And it is reinforced with fine number of 16 mm diameter bars in the tensile zone. So in the tensile zone, what is the reinforcement it is provided? It is 5 bars of 16 mm diameter each is provided. And the section is subjected to a factored shear of 52.5 kilonewton. So what is given here? VU is given here. So VU is 52.5 kilonewton. What is asking to find out here? Check the shear stresses and design the shear reinforcement. Here is asking to design the shear reinforcement. If the materials are M20 grade concrete and Fe415 grade steel. And here he has mentioned the grade of steel for the stirrups also. For the stirrups he is asking to provide the mild steel bars. So first let us write down the given data. So what is the given data here? The T-beam, the breadth of the web is how much it is? 230 mm. And what is the effective depth? Effective depth is given as 460 mm. D is 460 mm. And how many number of bars? 5 number of bars, and the diameter is 16 mm. Okay. And what is given? The factored shear, that is the value of VU is given. How much is the value of VU? It is 52.5 kilonewton. And the grade of concrete is given as 20 Newton per mm square, and the grade of steel is given as per mm square. And here is asking what? He is asking to design for the shear reinforcement. So what is the first step what we have to do here? The first step is we have to find out the nominal shear stress tau v. So first let us find out the nominal shear stress. So what is the formula for finding out the nominal shear stress? It is Vu by BD. Okay. So what is Vu here given? Vu is 52.5 kilonewtons. That is 52.5 into 10 to the power of 3 newtons divided by B. What is B? It is breadth of the web, which is 230 mm into D. D here is 460 mm. So if you calculate this, you will get a value of tau V, which is 0.496 Newton per mm square. So this is the nominal shear stress value. So what is the next step what you have to do? We have to calculate the shear stress or the shear strength of the concrete. That is, we have to calculate the tau C value. That is, the shear strength of the concrete has to be calculated here. So how will we calculate the shear strength of the concrete? The shear strength of the concrete can be calculated from table 19 of IS 456-2000. So in table 19, what we have? We have different values of tau C for different percentages of steel reinforcement and grades of concrete. So first what we have to do? We have to find out the percentage of steel. So what is the formula for calculating the percentage of steel? That is AST by BD into 100. So AST, how we will find out AST? It is 5 into pi D square by 4 divided by B. B is how much it is? 230 and D is how much it is? 460 into 100 will give you the percentage of steel. So if you calculate this, you will get a value of 0.95. Now what is the percentage of steel value? It is 0.95. And what is the grade of concrete? It is 20, M20. So from table 19, you have to find out the tau C value for this percentage of steel and the grade of concrete. If the value is not available, then you have to interpolate you have to take the previous and the next values of this particular percentage of steel. You have to interpolate, and from that you will get the value of tau C. And that is nothing but the shear strength of the concrete. So if you find out, you will get a value of tau C as 0.608 Newton per mm square. So from table 19, for this percentage of steel, that is 0.95, and for grade of concrete M20, the tau C value is 0.608 Newton per mm square. Now what? We have known tau V value, that is the nominal shear stress value, and the shear strength of the concrete, tau C. So now what is the next thing we have to do? We have to compare the tau V and tau C values. So now let us compare the tau V and tau C values. So what is the tau V value we got here? Tau V is 0.496 Newton per mm square. And what is the tau C value we got here? It is 0.608 Newton per mm square. So these are the two values of tau A and tau C what we got here. So from this what you can observe? That tau V is less than tau C. So what? Tau V is less than tau c. So if tau b is less than tau c, what? The nominal or minimum shear reinforcement has to be provided. What you have to provide? You have to provide the minimum shear reinforcement. So now what we'll do is we will provide the minimum shear reinforcement. So the next step is to provide the minimum shear reinforcement. So I am providing two-legged stirrups of dia 6 mm. So what I am providing here? I am providing two-legged stirrup and the diameter of the stirrup is being 6 mm. So from this I am going to find out the area of the vertical stirrups. So what will be the area of the stirrups? 2 into pi. D here is 6 divided by 4, which will give you a value of 56 mm square. So the area of the vertical stirrups what you are providing here is how much? It is 56 mm square. So mostly what in the previous sessions we have discussed, that mostly we are going to use the vertical stirrups. So design also we are going to consider for the vertical stirrups itself. So here I have provided two-legged stirrup of and the dia of the stirrup being 6 mm and I have got the area of the stirrups as 56 mm square. So after finding out the ASV, what is the next thing we have to do in the design? We have to find out the spacing of this shear reinforcement. So at what spacing you have to place the particular reinforcement is what we have to find out. Now in the next step, let us find out the spacing. That is, we have to provide the minimum spacing which is required for shear reinforcement. So let us find out the minimum spacing for shear reinforcement. So now we have to what? We have to provide the minimum shear reinforcement. So what is the formula for finding out the minimum shear reinforcement? It is ASV by B into SV greater than or equal to 0.4 by 0.87 into F5. So this is the formula for calculating the minimum spacing. The minimum spacing for shear reinforcement. So we have known all the values. We have known ASV, we have known B, and we have to find out here the SV. And the grade of steel is also known. Here the grade of steel should be the grade of steel what you are using for the stirrups. So in the questions it is already mentioned what the first stirrups, mild steel bars may be used. So what is a mild steel bar? Mild steel bar is Fe 250. So what will be the value of Fy? The value of Fy will be 250 Newton per mm square. So substitute all the values here. What is ASV we got here? ASV is 56 divided by B is how much it is? 230 into SV 0.4 divided by 0.87 into 250 because the grade of the stirrups mentioned is mild steel bar. So from this you will get a value of SV as 132.4 mm. So the spacing what you have to provide for the shear reinforcement is how much it is? 132.4 mm. So hence what? By considering the minimum spacing for the shear reinforcement, you have got a value of SV as 132.4 check for the maximum spacing of shear reinforcement also. So now in the next step, let us check for the maximum spacing of shear reinforcement. So now let us check for the maximum spacing. So in the maximum spacing, how many cases we have? We have two cases here. One is, as we are considering the vertical stirrup here, one case is the maximum spacing should not, or the spacing what we are providing, it should not exceed 0.75D, and the other one is it should not exceed 300 mm. That is the spacing what we are providing. So first let us calculate this. It is 0.75 into D. What is D here? D here is 460 mm. So if you solve this, you will get a value of 345 mm. The other one is 300 mm. So what is the previous spacing what we got here? We got here as 132.4 mm. So out of these three, which one you have to consider? Whichever is least, that value is what you have to provide in the design for your shear reinforcement. So out of these three, which one is the least? This is the least value, and this value has to be provided. So what here? We have to provide two-legged stirrup of dia 6 mm diameter, spacing center to center is 132 mm throughout, of grade FE 250. That is, we have to provide the stirrups, a two-legged stirrup, and the dia of stirrup is 6 mm, and the spacing between the stirrup center to center is 132 mm, and the grade of the stirrup is FE 250.